Yes, this is ET part 2. Today I am going to discuss some source conversions, types of sources, and some basic principles of DC circuits, just to solve the DC circuits easily. So first let's see the source conversion. What is the meaning of source conversion? In previous part 1, I have made you understand that what are active and passive elements, what are different type of dependent sources, and how a practical voltage source and a practical current source can be symbolized. So here, if there is ideal sources cannot be converted from one source to another. It is important to note, if in a question or in a numerical it is specified that it is an ideal source, then we cannot convert it from one source to another. But if it is a practical source, it would be having some internal resistance and it can be easily converted into one source to another. For example, first we are taking voltage source to current source. If in any numerical it is needed that value of voltage is not needed but value of current is needed, so we can convert voltage source to current source. How will we convert? First we have to find any voltage source with some series resistance or internal resistance. The internal resistance of voltage source will always be connected in series. This particular figure with node A and B and a voltage with series can be converted or is equivalent to a current having the same resistance in parallel, and the value of that current will be equal to V upon R. V and R both are specified. Similarly, if you have to convert current source to voltage source, current source to voltage source can only be converted when there is given a current source with a parallel resistance. It is very important to note that it can only be converted when there is a given current with a parallel resistance. Now, if this is given with a node A and B, it is equivalent to a voltage source having a resistance in series, where voltage source will be having V is equals to IR reading, and R will be the same, which is first connected in parallel, now connected in series along node A and B. Some important points to note here, that current always flow from positive to negative terminal of the circuit. Now let's see again this circuit. Here plus and minus polarities are shown and the current is flowing from plus. If this circuit is closed, then to minus. In this way the current is flowing. Here when we'll convert this particular voltage source and current source, the arrow will go in the same direction in which the current is flowing. Since current is flowing in this direction, hence arrow is showing upward. In similar way, when we are converting current source to voltage source, we have to first see the arrow of the current source. If arrow is showing the direction of arrow is positive and the other side is negative, so we will take the polarity of voltage source as shown by the arrow. Please make it clear, and it will be more clear when you do more and more numericals out of it. Let's see further. Next is source combination. Now it is important. Source combination can only be done when there are series connected voltage source and parallel connected current source. If there are parallel connected voltage source like this, voltage source parallel connected, they should have same value. They can't have different value. Then this network will be wrong. If V1 is not equal to V2, that this network will be wrong. If the voltage are connected in series, they can be add and subtracted accordingly their polarity. As I have taken an example here, there are two voltage source with same polarity and one with the opposite polarity. So we'll see the majority voltage. Majority voltage is plus and minus. This will be, I am taking as plus, this will be as minus. So my total voltage now will become 10 plus 10 minus 5, because 5 volt was in opposite polarity. So that is equal to 15 volt. Now this is the voltage sources in series. Let's see current sources in parallel. Now current sources cannot be in series. As you can see, when the current sources should be in series, they should be equal, because in series the current is equal. If I1 and I2 have different values, this particular circuit is not it's not right, it's wrong circuit. So here, to make the circuit right, there should be always I1 is equals to I2. And if we want to find the equivalent current in the circuit where there are currents in parallel, this is the way. We have to see the arrow. The arrow direction shows the polarity, and the one which is going out of the node, since there is no resistance between these nodes, these both three nodes, or these all three nodes are on same voltage, hence we have to take the current moving towards the node as positive and the current leaving the node as negative, and accordingly I have find the node current as 15 ampere. So let's see now combination of both. If there is voltage and current both but in parallel, then we will see that the voltage source is the main source. For example, I have shown here. And if there is voltage and current in series, the equivalent source will be the current source because they are in series. So please note these small things just to solve the numericals easily.